So welcome to the Partner to CPD program. Today we're talking about machine learning. So a big welcome and thank you to Google and specifically to Alex for supporting us with this program. We are, as always, joined in our audience today by education providers, our Technical Education Advisory Board, or TEAB, some colleagues from NCFE, and indeed IT departments from across different organizations and our network, both internal and external. This is the third program, third part of this program, I should say, that we've partnered with industry leaders from across the digital sector to bring you useful and informative content to support your own development and that of your students. My name is James Lane. I'm the Sector Manager for Digital, Creative and Design here at NCFE. I just want to briefly cover some of the housekeeping. As for questions, as with all of our sessions, we have the question box over on the right-hand side. And go ahead and ask any questions you have there, and we'll monitor that for them coming through. Of course, we'll do our best to cover everything today, but in the event that we're not able to, we'll be sure to follow up with you afterwards, and this can include specific questions about today's topic or something that relates to a separate session. We're at this point, this is the third session on the Google program, and we are arranging other sessions, and we'll have you those details over to you as soon as possible, as soon as we've got those confirmed. With that said, it's so exciting to bring this program together, and I know I speak for everyone here when I say that I can't wait to hear what you're sharing with us today, Alex. So let's get straight into it, and I'll pass it over to you to get started.
Good, thanks a lot. So I'm waiting for the rights to share my screen. Okay, show my screen. Yes. So you are able to see my screen?
Yes, we can see that.
Okay, very good. So let's start then. Up. Go back to. Okay. So thanks a lot, everyone, for joining us today. So I'm Alexandre Rodrigues. I'm working as a customer engineer at Google Cloud, and I will explain what Google and what's about this machine learning thing and also market, because it may have a lot of impact on many of your on many of your students. And maybe at some point they may have some career on that particular field. So it makes a lot of sense to at least understand what is it. So here is the little summary and what's going on next. So I'm born and raised in France, obviously. My accent should already speak for that. I studied electronics, so at the A-level equivalent. I've done 5 years of apprenticeship, which was a really great choice during my studies, because I was able to train myself as a professional, but also get all the important credentials to make me able to perform on this particular field, IT. I was first an HPC engineer, so working on large parallel systems to analyze potential risks in the financial markets. And then I went to IBM as an HPC specialist, HPC sales engineer. And since 3.5 years, I'm working at Google Cloud as a customer engineer, which stands for the pre-sales people in charge of making some architecture and everything available. Oh, and as a matter of fact, I'm also a teacher in 2 different schools during my my leisure time. Let's hope I have more in a few months. Okay, so I will start really briefly with this particular image. So how can we differentiate those 2 different things on my screen without machine learning? So we could talk about the texture of the object. Definitely, you have some little holes on the orange side, while there is no hole. It's really a really sweet texture on the Apple side. We could talk also about the colors. Definitely, they are different. The form of the two different objects, so an apple and an orange. We have different ways to try to differentiate it without a machine learning system. So definitely we can tackle that without needing some extra or specific research. Then let's go a bit beyond. Now we have Mongo. That one is a little bit trickier because the colors are a bit different, like an apple. It doesn't have the shape of the two others, but it starts to be more complex to make sure that it's not an apple and definitely a mango and not and nothing else. Then if we go to the next slide, we have another problem. So here it sounds like really obvious, but definitely we have to check. It's not only about colors, it's about, yeah, where is the nose, maybe where are the eyes, the kind of teeth the dog has, while on the opposite side it's pretty obvious. Okay, so let's go then to the last one. Here it starts to be very challenging. It's a real dog, so no issues with that. And as you can see, differentiated it between the dog and the object. It's really complex. It's really not obvious to understand the difference, but you are able with your brain to understand it. The main problem is to explain to a computer how to differentiate them. That's why machine learning matters. Machine learning in a theoretical standpoint, it tries to mimic. I really want to emphasize on trying. It tries to mimic the way a brain works. What I mean with that, a neuron is connected to various other neurons. It has inputs, and then once a specific level of energy, electricity is reached, then this neuron will fire a signal to another neuron. So that's the way we try to mimic our brain. Our brain is definitely more complex, but it starts with that. So we have several inputs. We have a mathematical function in an artificial neuron, and then the output will depend on those inputs. So as you can see on the right, we have a basic neural network with different inputs, then an hidden layer with our mathematical function, and then the output layer. So okay, it's a dog, it's an apple, it's an orange, anything else. So pretty easy and pretty basic. As you can see, it's not always easy with that to make an efficient machine learning system. What I mean with that is that when you look at our brain, we have several hundred billions of neurons working together with different specialties, but working together nonetheless. While on this specific machine learning or artificial neural network, we can see it's pretty easy. You can't have a few different compute, a few different mathematical functions to tackle something. You have one input layer, one hidden layer, so the one with your mathematical function, and then output layer. So too easy for the kind of problem we want to tackle, such as recognize an image. That's where deep learning started. I really want to emphasize with that. Deep learning was really a breakthrough on the on machine learning research field, and more specifically in understanding and recognizing objects or any other kind of important feature we want to extract from a picture. It's really the deep learning neural network who made this possible. And why is that? Is that instead of having one hidden layer, we can have multiple layers with different inputs. So the very first input layer with an image is a group of pixels. Then, depending on the color, patterns, etc., the first mathematical function will fire or not a signal. Then to the next layer, etc., up to the output layer with the answer we expect. And so to do that, we need multiple millions, multiple billions, a few hundred billions. As of today, that's the biggest neural network we know, at least yet. But all those layers have some parameters with specific mathematical functions, and it's really complex to I would say that to parameter them. What I want to tell is that if you change a little thing on the layer 1, then the layer 2 will be affected, layer 3 again, and so it's really not easy to be able to change all those parameters. So why we are able to do that? We use accelerators. So what I mean with accelerators, it can be GPUs with machine learning accelerators embedded or not. It works great even without them, but it's best to have them. We can have also some specific devices such as TPUs, so a little USB key or a little PCI Express card you want to add, and then with your framework. So a framework is a set of tools to do machine learning, such as TensorFlow or PyTorch. With all those tools, you are able to accelerate and parallelize all those configurations, which means that instead of waiting a few hundred months, years, thousands of years to get your mathematical function working, so your full deep neural network, with all those accelerators, you're able to train your model. Maybe one important thing, when I talk about training a model, it's about modifying all those parameters on our deep neural network or neural network even, to change all those settings until we get an output layer with an interesting result. What I want to talk about interesting results is a good amount of I don't know the name, but some good amount of sureness. Maybe not the best word, but definitely you want to know if the output is exactly what you expect. For example, it's an apple, it's an orange, it's a mango, it's a dog. And with that score, so what's it? You want also to have the score of, okay, it's really like a dog, or we're really not sure, like 550%. Okay, it's not good, very good, but it looks like a dog. If you're like near 100%, yeah, it really does look like a dog. So with all those information, we train, we train the model. When I say all those information, I mean images and also labels. So this is a dog image, this is an apple image, this is a dog with an apple, etc., etc. And all these data sets will be your training data set to train your neural network model. Once it is trained, it goes to validation. You want to have a little or a few tenths of % of your data set, which will be used for testing purpose. Okay, does it work on this particular data set? Because what you want to avoid during the machine learning training is the overfitting or underfitting. Overfitting is your machine learning algorithm is really good on your training data set, but it doesn't work on the real life data set because they are not exactly the same as the data set you have in input. And the underfitting is the complete opposite. It really not work, so problem. So what you want to do to have something that is efficient, you will have a training data set. It's the biggest part. It will be used to train your algorithm. And then you have the testing data set or even a validation data set. So three different potential data sets just to make sure that your training goes the correct way. And then you will ask me, okay, since the machine will do all these tuning parameters, what's the main goal or main purpose of a data scientist or someone really specialized into machine learning topics? So his main goal is to make sure the training goes well. And how he does that? First, he has some experience on machine learning, so he understands the way he should set the first parameters, the different checkpoints to make sure that the training goes well and avoid spending time if the training doesn't go the way it is expected. And he is also sufficiently expert that he knows how he needs to tackle or the way he needs to treat the training data set. What I mean is that we have images. Okay, let's see. We have 50 images. Okay, 50 images, if they are simple, such as, okay, it's a dog, it's an apple, it's an orange, it's a mango. Okay, we have maybe 1 hour of work to tell, okay, it's a mango, it's an apple, so it's pretty easy. The problem with 50 images, you're really not going to tackle anything interesting. It's really too small to get interesting results. You will need much larger model and much larger data set. So how do we do that? The first reflex we can have is, okay, let's take more pictures of the mango, more picture of the dog, more picture of, and then you finish with a few thousand, a few 10,000, a few 100,000, a few millions of pictures, and then you're happy. But you lost a few years to get everything done. So not the best way. Second way, you pay someone else to take all those pictures and to label your data set for you. It works pretty great, but it takes time and it also really not cost efficient. Okay, so what can we do then? We have several mathematical functions we can use on our pictures, on our training data set to create a new, a larger data set. What I mean is that we can, for example, rotate a picture. It's still a dog, but it's rotated, new image, really easy. And you can rotate it a few hundred of times, depending on the angle you want to add. You can also change the contrast parameters. So the image will not look exactly the same as it was before, but it's not a problem. What we want to be able to do is to recognize a dog, a mango, etc. So we add new data set, even if it's not exactly real life data set, it's definitely useful for our model. So that's also a way to perform that. So it's also really the job of data scientists to understand that. And then last but not least, it's the data set quality. What I mean with that? Okay, we have 50 pictures with dogs, etc. We used all those transformative functions to create a new data set, really good. And then we start with our camera outside of our house and it doesn't work. Why is that? Mainly because you have to have some pictures that are really related with how and where you will use it. What I mean, for example, let's say you all your data set is only black and white pictures. Then definitely you want to make sure that once you want to test your data, your model, you want to have a black and white camera. If it doesn't suit your need, then okay, you have to have some color data set, and same, you want to have a color camera at the end. You may also need, if you want to have something that works with a webcam, a camera, any other kind of devices to register images, you want to have a data set that really looks like all, not exactly all, but at least a large part of all those data sets examples. So it's really a complex job, really passionate, fascinating job, but it takes time and retry, error and retry to get someone really expert on that particular field, and also some time to learn about new algorithms, because it's not only, okay, it's a machine learning algorithm or it's a deep learning algorithm. You have a lot of different mathematical functions that can be used, and they may rely or not on deep neural network, or they can also rely or not on machine learning itself. You have a few hundred of algorithms that doesn't use machine learning, but either way, they will train on your data set, and they will be able to understand your data set if it's well designed. So you have a lot of work, pre-work and after work to get something interesting. So that's really what I wanted to tackle on that. The job of a data scientist, the different machine learning or the two main families of machine learning model we can have. And then let's go to the next part. Why we are for which purpose we want to use machine learning. We want to have an algorithm that are able to generate insights, so knowledge from learning from the data. So for example, is it a dog? Then how we can recognize a dog? You don't want to explain all the potential difference between a dog and an apple. You want to have the algorithm able to understand. Why? Because if you try to create this algorithm, it will take a lot of time to do so. And once it will hit the market, someone else will do better with his own algorithm, maybe using machine learning. So you want to have something that is faster to learn and able in a few hours, in a few minutes to understand your data set. And then how it does that? It finds patterns in the data. So if, and it's really important, like if you have 50 pictures, but it's 50 different objects that are not related, and you want to be able to explain your machine learning algorithm, what's the difference between them, you will have really poor results. To be efficient on what he's doing, he will need like around 50 to 100 pictures of every single item. You can have a bit less, you can have a bit more, but then we go back to machine learning experience. You want to have a data set that really looks like what will be the real world examples. For example, if you provide 50 examples of dog and only one for apple, then your final usage will have like 50 times more often dogs than apple. Why is that? It's because the machine learning will try to understand your data set, find all those patterns, but it will also keep a track of the amounts of images, and will tell, okay, at the end, if I want my machine learning algorithm work, or if I want to have the best potential score, I should 50 detect a dog 50 more times than an apple. And then you will tell me, okay, very good, let's go. It's not finished again. If your data set is like 50 times one kind of one label, so one kind of object, and only one time the opposite objects, then for your machine learning algorithm to be really efficient, it's really easy. It should always tell you, okay, that's definitely a dog, no problem. And with that, you will reach 98% of accuracy. Crazy. And he did not learn anything from that. So you really have to be careful. What's your data set? What's your usage? And then do the math and the job to get your machine learning able to understand. So really important or interesting thing, machine learning is not that new. The first methods, statistical methods we know was created like around the 1950s years. So it's really old. The only problem with those algorithms, since we were not able to get a lot of data sets, a lot of compute power, it started like really easy on maybe understanding, for example, letters. The NIST data set is really like 0, 1, 2, 3, 4, 5 up to 9. And this data set is to make a system, an automatic system such as machine learning, able to recognize unrated numbers. So really simple use case, but really interesting, because with that you can start on OCR, so an automatic system to recognize numbers, for example on checks, and tell, okay, that's a check for 1,000 pounds and not 100, which makes a lot of difference. So you have everything needed as a mathematical standpoint exists since a long time. The main problem was, okay, but what about my data set? What about my compute power? And also, what about the different machine learning frameworks to make it able to work really easy? because if you look at the numbers of researchers in machine learning, deep learning fields, there are like a few tens of thousands, no, not more. If you look at the people really able to work with all those numbers, you may reach like around a few millions, but a few millions in the whole world. So to pay them, it's really hard. To find them, it's really hard, and to keep them on your company is also a major challenge. Why is that? It's mainly because if you have like a really interesting project, you may be really happy to hire them and get them able to tackle this project. But if you have nothing else, you will start to, okay, what should I do? And then he will try to work somewhere else where his skills are needed. That's also why many different companies, instead of hiring them directly, use another company or contractors to get the job done. And then once it's correct, it works, then okay, you can get back to any other project you may have in any other company. So that's also something interesting. It's hard to hire a data scientist, and it's also even more harder. It's even harder to keep them on your company. So you want to have a real use case with a lot of different projects and a long time to get everything work if you want to keep them for a long time. Okay. And yeah, the Bayesian theorem, just a matter of fact, if you look at the bottom of the screen, 1763, and it's already since even today one of the most used and most reliable data scientist technique to understand a data set and being able to separate them. But with numbers, or I would say that with structured data set, not with images. But definitely interesting to see that going back, if we have a lot of today technique, like in 2022, that still relies on a very old theorem, and it works great. So also something for your students, they should, I would say that, look at things such as deep learning, etc. But they should not stay only on those particular fields. It's really great, but it's not the alpha and omega of this particular field. They should not hesitate, go back to the basics to get their job done. And then you will see the difference between the person trying to surf on trending words and the other person that is really an expert and tell, okay, that's how we should tackle this problem. About the potential usages of machine learning, definitely it's huge. I don't know many companies that may not need it. It's really from a factory. Okay, how can I detect a defect on my product before it goes outside of my factory? And you will see that a person checking them is good, maybe even great. But the problem is to keep pace. Like if you have 100 or 1,000 or 10 of thousands of those objects going outside of your factory every single day, you can't check them, or it will cost a lot with a human. Having a high-speed camera or any other input to check the quality of your product is really a better way to get things done really fast and really reliably. What I mean with that is that your person on may have some vacations, maybe sick or anything, and you don't want to close your factory until he goes back. You want to have something that works. Okay. Maybe something also interesting. We have more and more engineering schools adding some data science classes, and interestingly, it's not only for the data specialists. Anyone can go to those classes and understand a bit more a few different solutions or potential solutions for big problem we can have in industries. And it's really fascinating because I was talking about the quality check on a factory. I have another example that is really crazy. I know a person working on for a major sugar producer in France, and every single time they get some how we call that, vegetables, every single time they get them and prepare them, cook them to get this sugar at the end, every single year, since we don't have always the same weather, we don't collect the vegetables at the same time, you want to have a way to cook them that always work. And so this company pays a large amount of money, a few person that are really expert on that. They look at a few batch of those cookings and they says, okay, that's the correct parameters. And why they use that? First, it makes them able to get a better recipe, and so being able to produce them faster. But also they can save a lot of I will call that gas, but it's not exactly that. It's fossil fuels. I will call that. It's not exactly the term, but to save them. And so you can save a lot of money by having at the very first time the correct recipe. And now they still use all those specialists, but instead of having them meet every single factory, they just work on a few numbers that are important for the batch, and then send the correct recipe to all the factories. And it's really faster, and they save a lot of fuel with that, and CO2, etc. So really a good use case. And strange as well, because I was not aware of that before he told me about it. Also, something really interesting, and why we see all those machine learning projects and this field trending now, it's also about the big data. Why I tell that is that, as I said before, to get a proper machine learning algorithm work, you need to have good quality data. And to have good quality data, you need to save, to capture the best data you can. And when I say best, is accuracy about this data and what you will see in real life. And also the quantity. If you have 10, a few hundred of images or a few hundred of values, your machine learning algorithm will not work. You need more. So that's why also with big data, we were able to save and dig into and do the data mining. But also with big data, you are able, if your data set is of good quality, you are able to train machine learning algorithms. Also, what was important, it's the person. Like I said, we have more and more machine learning and deep learning frameworks, such as TensorFlow, such as PyTorch, such as I can't remember the name. That's okay. I will send a few links after this presentation. But there are a few frameworks that are really well known and helps a lot of data scientists to tackle their work without having to what we call in France reinvent the wheel. ML chips, so machine learning chips, are also very important to get the machine learning training and inference. Inference, it's the detection part of your algorithm. You train it and then you infer on your dataset. And so having some chips that are able to accelerate the treatment are really important as well. And then also, I don't believe it's the biggest part, but definitely a really important one. It's the cloud services. Instead of having, to buy a really large computer, a lot of GPUs, hardware for the storage as well, and having something that may or not work, but you will have to treat really well and prepare really well, you can, in a few clicks, get a really strong machine that is able to tackle your problem. Do a few checks. Does it work? Yes. Okay, very good. Let's go to production. Oh, it doesn't work. No problem. We send everything in garbage, and we don't spend a few tens of thousands, a few hundred of thousands pounds in the hardware or in the software as well. We just have to test, and it may cost a few bucks. Okay, a few logos as well. Okay, so yeah, I wanted to talk about Keras, which is really used by many different data scientists, and embed a little bit TensorFlow as well. So a few logos about it. Okay, okay, I still have time. Good. A few logos. So Hadoop is really one of the angle stone of this ecosystem. So with Hadoop, we're able to save a lot of data. We are also able to work on these data sets with a lot of computers. So definitely something interesting to create a data lake. So somewhere to put your data and do the data mining. And then on top of that, you can start to use machine learning. You can start with machine learning embedded into Apache Spark. So it's the logo at the right. Spark does exactly what Hadoop do. What it does more specifically, it does the MapReduce part of Hadoop, because Hadoop is also a complex ecosystem with many different products on it. Spark is about replacing the MapReduce thing, so the most important part of Hadoop. And instead of using the data directly on the disk, which takes a lot of time, is able to work with the data set on memory, so in RAM. What it means is that you need more capacity in RAM to get Spark work, but then you are able to accelerate your job a few hundred times. So really interesting when you want to have something, for example, you have a website with a few items you sell from that eShop, and then you want every day to compute to find the best price for all your products. So instead of doing it by hand, or instead of having a few days to get your compute done, you can use Spark and accelerate it. It's really interesting. Bigquery. Bigquery is a product from Google Cloud. What's interesting with it is that it's able to work with a lot of different ecosystems. You can use it as a normal database, a data warehouse, but you're also able to run some machine learning algorithm with AutoML. So auto machine learning, you don't have to parameter anything. Let the machine do it for yourself. And it's really efficient. You have a few websites that are, I'd say that's challenges for data scientists, such as, okay, I have a data set, I have 10,000 ground, I want someone or some team able to tackle my challenge, and if they are able to do so, the first team will get all this amount of money. And so BigQuery with machine learning and AutoML is able to reach like around the top 2% of the answer to those challenges in a few hours, while the other teams takes a few days, a few weeks to get the things done. So okay, they do it better, no issue with that. But at the same time, they took much more money and much more time to do so. So really interesting to go with AutoML if you don't have a really well-seasoned machine learning specialist or data scientist on your team. And same thing, it's also can be used as a, let's say that a proof of concept platform. Instead of trying, and spending a few weeks to tackle a problem, maybe just feed a tool such as BigQuery, a machine learning algorithm, and see if it can find all those patterns on the data. Does it? Okay, let's dig on it. It's really interesting. It looks like our machine learning algorithm is able to do something. But if it's not the case, maybe we should not spend much more time on it, or maybe we need to work again on data quality. Cassandra, a NoSQL database, I see a lot on the banking ecosystem. Really interesting to get a really good amount of acceleration in things such as time series. So if you have one value that changes from 1 hour to another, for example, the consumption of a family in energy or water or whatever, you can store it really efficiently on Cassandra and then get your machine learning algorithm work really fast with that. Elasticsearch, same thing, but instead of collecting time series, you work on keywords. So you collect how much time a word was used or a value, etc., and then you're able to find it really easily, really efficiently. Nifi, Apache Nifi, really important tool as well. Instead of having to work or to create a proper data flow with step 1, step 2, step 3, let's do a lot of code to get them able to communicate, work together, etc., and able to survive things such as at some point my machine stopped unexpectedly. How should I restart it? Nifi will help you connect different databases, different data sets, perform what we call an ETL, extract, transform, and load. So really important part to get your data set correctly formed and then go to the next step. So I talked a bit about the different frameworks, machine learning frameworks before. So I believe you're already done with that. Maybe just look at the right. I don't know if you see it, but you have a few examples of potential machine learning accelerators. And they are really interesting, such as the USB key called Coral at the right. I have one in-house. It's a few tens of euros, so really cheap. I was able to detect cats on my garden in a few hundred milliseconds with my CPU. So really happy, but not so much if you have a few tenths of frames to check every single second. With that Coral at few tenths euros, I was able to do it in 13 milliseconds, and it's working every single time in 13 milliseconds. So really interesting accelerating factor. And when you look at the story, I booked my laptop. It was in 2K18, late 2K18, and it worked great. But I spent a lot of money on that, like around 1,500 something, to get something that is able to tackle machine learning problems. With the little Coral things on the right, it's a few tens of euros, and it works really faster. So crazy to see the evolution here. A little bit about same thing about cloud system. So software as a service, for example, for your data scientist or people willing to become a data scientist. The first one I would encourage to use Google Collaboratory. It's completely free. You can't use large models, or you can't use for a few tens of hours your algorithm. But for testing purpose, it works really great. And Collaboratory is so powerful. You can use existing algorithms such as notebooks. So Jupyter notebooks. If you don't know it already, and if you want to learn data science, definitely start on that. Data science with Jupyter notebooks. So Google Collaboratory is a solution. You import a notebook, or you use an existing notebook, and you are able to start working on the data set and see the result of different machine learning algorithms. There is a paid version of Collaboratory where you can use more powerful systems if you want to accelerate your data sets. But really, for testing purpose or even teaching purpose, Collaboratory is free and is really, really powerful. Vertex AI is a system much more for enterprises, so enterprise ready, with a lot of different modules to get all this ETL, extract, transform, and load, preparation of your data set, training your data set, host or export the machine learning model where you want to use it. So a really complete platform for data scientists. And you have also some really interesting algorithms such as AutoML vision. So with that, instead of providing a lot of images, start to learn it, to create a machine learning algorithm from that, you don't have to care. Like if you want to know if it's a cat, a dog, or whatever, you provide it to AutoML vision, and if it's common objects, then definitely we'll be able to recognize it, which makes you able to use machine learning in a few hours instead of a few weeks to get something interesting. It's also able to learn a new use case. Since we at Google, we have a lot of data sets with images, with structured and unstructured data, we're able to make a few really interesting AutoML algorithms. You can specialize them. What I mean with that, instead of training a machine learning algorithm from the ground, you take our algorithm and you specialize it on your data set. And it's really interesting because you may save a few weeks or even a few months of work, or even with a little data set, you can have some really interesting results, while it can be really difficult if you go from the start. Okay, so 5 minutes again. Okay, so the machine learning main challenges, I already talked about it before. So you will have a slide with that, no problem, no issue. Explainable AI. It's really interesting because the main criticize we can make about machine learning, it's I don't know how it works. I understand the basics on it, the theory, no problem, but how my algorithms knows it's a picture about flowers, or it's a dog, or it's etc. And why you want to know that? It's to make sure that you are not on this overfitting or underfitting things, such as if your algorithm is able to understand it's a dog because every single time you provided it an image of a dog, it was a red background around it. It will not work if it's not a red background before in the background of your next pictures. So the explainable AI, it's totally about that. It's making able to show you what's the different part of, for example, an image or a data set that makes him able to, or at least think that it's a picture of a flower, it's a dog, or even on your structured data that it does think that the next value will be that and nothing else. So that's very interesting because it makes a company or researcher able to know if the algorithm is really working as expected, as it intended, and it will not have some strange behavior on the real life part. And it's really a really difficult problem. It took a lot of years to our engineers to get something that in most of the time is really usable. But as you can see, test your model preview, it says everything. We are still tackling this challenge. It's not definitely done. And we talked a lot about the usual usage of machine learning in different industries, in different parts of the job market. But it's also about research, definitely, and something that was announced a few months ago. It's the possibility to use a machine learning algorithm, a deep learning algorithm, to be able to understand better the proteins. What I want what about understanding them better? Proteins, we know for most of them the way they form and the way they interact with their environment. But it's really difficult to get like a dictionary of every single interaction or every single things that can happen. It takes a lot of researchers to check things and to understand if it works or if it interacts with the environment or not on this particular field. And so we created with several important institutes, so we were not alone doing so. We worked with Max Planck and EMBL, and we were able with them to create an algorithm that is able to predict most of the protein structures. And with that information, we can start to understand that what are the odds, what are the chances that at some point this protein will interact with another protein or any other thing on his environment that may be impacted by that particular or those particular proteins. So it's also helped to create new drugs, such as, okay, my drug may or not, or my molecule may or not interact with those proteins. And at the same time, it makes able to understand what may be the harm or not of those medicines. So really important stuff going around. If you're interested about this particular topic, I would encourage you to go to DeepMind and check our different articles, a blog post. Really interesting if you want to understand the way we tackle that before going to the paper, the peer-reviewed papers we communicate. And if you want to go to peer review, no problem. You have all of them. And if at some point you want to understand, for example, eye blinks or whatever, and how does machine learning can help, that's papers we provided. So thanks a lot for your attention. We have 10 minutes for the questions, so don't hesitate.
Excellent. Thank you very much, Alex. That's brilliant as usual. Just before we check on any questions, I think I'm sure, like many people listening today, I've immediately gone onto a variety of websites and tried to order a Corel USB accelerator. So I look forward to having a play with that. Did I hear you say that you documented your experience or your journey with one? And if so, is that something you'd be willing to share? Maybe like a tutorial, what you did with it?
Interesting. I can share a bit, but to be honest, I relied on work from other teams. You have TensorFlow, and with TensorFlow, you have a framework for PCs, and you have a framework for smaller systems such as Raspberry Pis, and accelerators such as this one, this little guy called the Coral AI. So once you have the TensorFlow Lite, you don't have to train him to get some interesting results on things really simple, such as recognizing a dog, a cat, a person, etc. You just feed TensorFlow Lite. You start. You have a command to start the model and to load the model on the TPU. So the Coral AI products your model, and once it's up, you can start to feed him with your images. You don't feed him complete images because it's a waste of time. Images too big are too complex to analyze from TensorFlow Lite. TensorFlow Lite is kind of an entry point to computer vision, not the best experience you can have. You should use, for example, computer vision to get this best of the breed experience. But instead of using that, you can use OpenCV, so Open Computer Vision, which is a really simple tool to create pictures every time you detect a change on the image. So every time you detect a movement anywhere, you create a little picture of this change, and then you feed your Coral AI model, your TensorFlow Lite model on the Coral AI with that picture. And every time it says, okay, it's nothing, or like a tree, or oh, it's a person, or oh, I think it's a dog or a cat. And then you start to tweak because it says a lot of things. It will not say, okay, it's a person. It's too easy. You should know. It will analyze the picture and says, okay, I believe it's 70% a cat, 50% a dog, 30% a person, 20% an elephant. I don't know why, but it may be an elephant. Not in my garden, at least I hope. So it will tell you everything, and what you will start to program. That's where you need some developer skills. It's to tell, okay, if my answer is up to I don't know 70%, I ignore it. But if it's beyond 70%, maybe it's that. And then you can feed a website, or you can feed an NVR, so a network video recorder, with all those images. So you are able to follow up what's going on in your garden, and what about the cats that pass on it.
Brilliant. Excellent. And just maybe hopefully a simple question. It might be just a coincidence. Is TensorFlow related to Google Tensor the chip, or is that just a coincidence in naming?
Yes, completely. So TensorFlow is a framework, an open source framework available for everyone to analyze and use in production, or even to test or do the research. And at the time we created TensorFlow, we relied on GPUs, so graphical processor units, so such as NVIDIA or AMD GPUs. It worked great, but it's not really the same as doing some compute for graphical purpose. What I mean with that, a graphical processor unit will do a mathematical transformation, such as, okay, I moved my camera on my game, for example, my video game. Okay, so that's all those points on my image. That's the translation, the transformation they will do. So I have a new image of my complete environment, my complete screen. That's how it works, and it works really great for that because there are plenty of different very small computer system and kind of midly large data registers, and so it will do exactly the same operation on many different points at the same time. So really great to parallelize and work on these 3D setups. The machine learning algorithm is really different. Instead of that, it will take different inputs, or maybe one input, but most of the time it's not 0, 1, or 2, 3. It's a lot of different inputs, such as different zone of your images. And then it will do a lot of different compute, functions on it to be able, and several times, several layers of this compute to get your image understood. So the TPU was really our first try, and we are at the third generation of that technology. Was really the way we explored to instead of having all this compute power available and doing exactly the same compute function, compute transformation on all the data set, which it doesn't work really great for machine learning. We are using a lot of different compute controller. It's not exactly the correct term for that, but a lot of different compute power, but not at the same time. We first use them for a first layer, and once the layer is treated, we go to the next layer, etc. What it makes us able to do? First, shut down many different compute parts that are not used yet, but will be used. And the second thing that makes us able to do, instead of having to move a lot of time the data because you do a transformation, you want to save it. Okay, then move it back to the input and then do the next transformation. It takes a lot of compute power to do so. Instead of that, you go first register, first function, mathematical function, first layer of mathematical functions. Really great. Let's start the second layer of mathematical functions, and instead of moving the data set back to the point one, you can work on that directly. So it makes the system faster and also less compute, less power hungry. So really great for that usage.
Brilliant. Thank you very much.
Yeah, you're welcome.
Sorry, I didn't mean to interrupt you. Sorry.
No,
okay.
it's
Brilliant. Well, David, you're with us still. Is there anything that you'd like to ask at this point?
It was really interesting, that, Alex. Thanks a lot for everything you've gone through there. And I can see how much Google are doing and how much they're pushing AI forward and ML and the amount of work they're doing with it. And I know when I was looking on Google, it was showing how they're using AI and ML for working with environmental factors and things like that. What do you think, in your opinion, will be the biggest industry or the biggest thing that AI will really make a big impact on?
It already started, and I don't see any field that may not use it. I don't tell you avoid any other kind of job. Let's go all data scientists. It will not work that way. But data science is really a game changer for many different industries. The very first one, the obvious one, is marketing. You want to understand your visitors, but you don't want to have someone like checking what is going on, what is doing on your e-commerce website, or what is doing on your shop, your physical shop. You want something to analyze the different behaviors, and then from that learn. Okay, we should maybe try to sell him this particular product because it's really related with what he's buying. Such as, okay, I'm buying some boots. Maybe he wants an umbrella. I don't know if it's a good idea, but at least I know for sure that I don't want to resell him the exact same boots. Most likely he will not rebuy them. And maybe I can learn also about the weather. So if it's sunny tomorrow, maybe he will need sunglasses and not an umbrella. And so you can use all those things to try to sell, okay, more, but also better. What I mean with that, instead of, for example, you want to do a promotion, a discount on some of your products, instead of buying, I don't know, 100,000 of those devices and maybe only sell 10% of it, or the contrary, you sell, okay, very good, there is a large discount, go to my shop, and then people go to your shop and there is nothing more. So they are really hungry and maybe they will not get back to your shop. Instead of that, you use all those machine learning algorithms to tell, okay, most likely with that kind of objects from the history and from other parameters such as the weather, such as the time in the year, and other things, I believe we should need like 300,000 of those objects. And you do two things. First one, you're more efficient. You don't buy for nothing objects. You try to kind of respect your customers instead of, okay, there is a really good promotion, but I have 2 devices. Okay, so they're already gone at 9 a.m. You can make sure that everyone will be happy to go to your shop and enjoy this discount and the promotion you made around it. And with all of that, we're trying to, when I say we, it's really the market. We're trying to make things more efficient. I don't know if it works all the time, but at least I can tell you that for the shops, it's really efficient. They can save millions of pounds per month by having this smart inventory system and able to predict how much of all the stuff that they need to buy. They really need to buy, and that they will not destroy at the end of the discount or whatever. And they also are able to target better people and be able to sell them things that matters. So that's really, I would say, the first very big use case they have, marketing and inventory on top of that, inventory management. And then around of that, I don't see any field that doesn't use it. You can use it for to launch probes on the space. You can use it to understand our climate changes. You can use it to do the quality check on the factories or any other kind of place where you put materials. You can use it to detect cats on your backyard. The sky is kind of the limit, sky and money as well, and data sets. You need data set to train your machine learning algorithm.
Brilliant, thanks, Alex.
You're welcome.
That's fantastic, Alex. Thank you so much. I think I'm just very mindful of the time, so we don't want to keep you any longer than we've committed, and obviously we've still got some people, so I'm just mindful that they may need to get back to teaching it, etc. But thank you so much for spending the time with us today and throughout the entire program. I think I've got a list of topics that I would love to pick up with you separately, so I would we'll deal with that separately, but I can imagine us wanting you to come back many times, but we'll talk about that separately, about other topics that we can cover.
Okay.
But genuinely, thank you so much. Thank you for everyone joining us. We'll end it here. Of course, we'll make this video available to you afterwards if you want to watch it again, or if you want to share it with your students. And we'll also send out the presentation that Alex has used today. But for now, let's end it there. Thank you for joining, and we'll catch you next time.
Thank you, James. Thank you, everyone. Have a great day.
You too.